In this video, we're going to conduct a hypothesis test for proportions, and so there are 5 steps you always need to show. You need to state your hypotheses, and so the first is your null hypothesis, which is always your parameter set equal to a value. And then you're going to test an alternative hypothesis, and there are 3 types of test. You can either have a not equal to test, a less than test, or a greater than test. And so once you state your hypothesis, you're then going to check your assumptions. You always need to check for a simple random sample, and you also need to check your central limit theorem. Once your assumptions are satisfied, you're going to calculate your z-score and your p-value, and then you're going to use the p-value and compare it to alpha. So you use alpha to either reject your null hypothesis, where the p-value is less than or equal to alpha, or if the p-value is greater than alpha, you're going to fail to reject the null hypothesis. So once you choose either to reject or fail to reject, you need to interpret your results. And so you're going to state that there is either sufficient or insufficient evidence that the alternative hypothesis is true. So whenever we reject our null hypothesis, there is sufficient information, but if you fail to reject your null hypothesis, there is insufficient evidence. So let's see how all of these steps work looking at an actual example. And so of interest is to test to see if the proportion of all adults in the United States that shop at Kroger as their primary grocery store is greater than 0.50. A simple random sample of 900 adults in the United States was selected, and each was asked what grocery store they primarily use for shopping. 32 adults indicated their spouse did the shopping and did not use a grocery store, so the effective sample size was reduced to 868 adults. Of these 868 adults, 460 indicated that they used Kroger and 408 indicated that they went to another store. If appropriate, use this data to test the hypotheses at significance level alpha equals 0.05. So in the first line of the problem, we can see that we're testing the proportion and seeing if it is greater than 0.50. So our null hypothesis is that pi is equal to 0.50, and our alternative hypothesis is that pi is greater than 0.50. Once you state your hypothesis, we can check our assumptions. And so first we see that we collected a simple random sample, so this satisfies our first assumption. And then we need to check the central limit theorem. In this problem, we're going to use pi naught and multiply it to our sample size, and make sure you notice that in this problem we have a reduced sample size, and so you need to use the proper sample size of 868. 1 minus 0.5 is still 0.5, so I only calculated this value once, but 434 is greater than 10, so both of our assumptions are satisfied. Now we can move forward by calculating our z and p value, and we can do this using a graphing calculator, which we will do in the next video. But you can go to stat test and one proportion z test, and you're going to enter in your x value, which is the number of successes in the problem. Here we're discussing those that used Kroger as their primary store, so that's 460 adults. Our sample size was 868. And then p naught in your calculator is going to be the value that you're testing, which for us is 0.50. So this is the number that is stated in the hypothesis. Once you enter all of these values, you can also enter the type of test that you are conducting, and your calculator should give you a z-score and a p-value. So once you calculate these values, we can use the p-value to interpret the problem. In this case, we are comparing to an alpha of 0.05, and so our p-value is less than 0.05, so we reject the null hypothesis. Once you state that you're rejecting the null hypothesis, we can say that there is sufficient evidence that the proportion of all adults in the United States that shop at Kroger as their primary grocery store is greater than 0.50. So this is just one example of a hypothesis test, and in our next video we're going to show how to use the graphing calculator.